Alright, in this video we're going to take a look at multiplying matrices a little bit more in detail and how it relates to the transformations for I hat and j hat. So in our last video we saw every time we multiply by a matrix it transforms I hat and j hat into new coordinates and creates a new coordinate system. So visually if we continue to multiply by a new matrix after that, it's going to take the I hat and j hat to new coordinates based on the current coordinate system we happen to be in. So, for instance, we have the product 2, 1 and 1, 2 by the matrix 1, negative 1, 1, 3. Well, what's going to happen with this first matrix here, this 2, 1 and 1, 2, is I hat is going to get sent to this first column, this vector 2, 1, and j hat is going to get sent to this second column 1, 2. So if we take a look at that on GeoGebra, and I'll put the link here as well, I hat is getting sent to 2, 1, and then j hat is getting sent to 1, 2. There we go. And there's our matrix. So now we have this new pink coordinate system where this represents 1 on the new x-axis and this blue vector represents 1 on the new y-axis. Well, according to this new coordinate system, we are then going to take our I hat and j hat vectors that we have, the red and blue vectors that are diagonal right now, and then I hat is going to get sent to this coordinate 1, 1. J hat is going to get sent to this coordinate negative 1, 3 along this new coordinate system. So if I hat is going to get sent to 1, 1, that means we're going to have to go 1 unit over and then 1 unit up. Again, the new j hat is on the pink grid. This is going up. So that's going to put a point right here. So let's just go ahead and put a point there. So we'll go 1, 1. There's a point right there. We'll call that point A. And then j hat, our new j hat, is going to be at negative 1, 3. So if this is 1 on the x-axis, the new x-axis, here's negative 1. And then we have 1, 2, 3. So this will be our new point there. So our answer, if we go back to what I hat and j hat originally represented, that didn't go the way I wanted it to, but I believe we should have one at 3, 3 and 1, 5. So see if I can go back to that. Yeah, so we have 3, 3, and then we have 1, 5. So I hat gets sent to 3, 3. So our I hat is going to end up at 3, 3. Yeah, here we go. And j hat ends up at, this is where j hat ends up at 1, 5. So that's where j hat should end up at 1, 5. So the product of these two matrices should be this one right here. So we'll take a look at the matrix multiplication the way we did in the last video as well. So our first one, I believe, is that problem. So multiply each of the following if possible. So we have 2 columns here, 2 rows here. That's good. We want that to happen. We're going to separate here, and we're going to take 1, 1, and we're going to multiply this matrix by that 1, 1. That's where I hat ultimately is going to end up. So I hat is going to end up at 2, 1, 1, 2 times the vector 1, 1. So we're going to take this 1, multiply by this first column. So 1 times 2, 1. Then we're going to take this 1, multiply by the second column, and add them together. And when we do that, 1 times this column is that column. Likewise with this other one. My penmanship is really bad today. And when we add these corresponding elements, we get 3, 3, which is where we said I hat should ultimately end up in relation to the original grid definition that we had, where I hat is 1, 0 and J hat is 0, 1. Now let's see J hat. I think we said the answer should be 1, 5. So J hats, we're going to multiply this 2, 1, 1, 2 matrix by negative 1, 3. So we're going to take this negative 1, multiply by that first column. Then we're going to add to it 3 times this second column. And we get negative 1 times this column gives us negative 2, negative 1. Plus 3 times this column gives us 3, 6. And when we add these together, negative 2 plus 3 is 1. Negative 1 plus 6 is 5. And then we can merge these two back into one 2 by 2 matrix. So that'll give us that answer we saw earlier of 3, 3, 1, and 5. All right. Now let's reverse the order. So now, reversing the order, let's see if we get the same answer. We did get the same answer when we switched the order of addition in the last section. Let's see if it's true for matrix multiplication as well. So we'll calculate it first, and then we'll see it visually. But we separate them where this is I hat. So I hat is going to be the matrix 1, negative 1, 1, 3 times this column 2, 1. So that's 2 times this column plus 1 times this column. And that gives us 2 plus negative 1 is 1. And then we get 2 plus 3 is 5. So I hat ultimately ends up at 1, 5. J hat. We got 1, 2 times this matrix. So we're going to take 1 times this first column and add to it. We'll just divide the 2 up here. 2 times this second column. Here we're going to get 1 times 1 is 1 plus 2 times negative 1 is negative 2. So 1 plus negative 2 is negative 1. And then 1 plus 6 is 7. So our answer here, we get I hat gets sent to 1, 5 in our original coordinate plane. J hat gets sent to negative 1, 7. So notice that the order in which we multiply our matrices did not give us the same answer. Here we got 3, 3 for I hat, 1, 5 for J hat. Here we had 1, 5 for I hat, negative 1, 7 for J hat. So the order in which we multiply matrices matters. We say matrix multiplication is not commutative. In fact, we can see visually if we first transform our coordinate plane for this first matrix. So let me just reset I hat and J hat. And we do not need this point. We do not need this point. So we said I hat goes to 1, 1. And J hat goes to negative 1, 3. And then I hat is going to go 2 units and 1. So 2 units and 1. So we can put a point there. So let's just go ahead and do that. So we have 1, 2 units and 1. Well, that puts us at 1, 5. And then J hat goes 1 and 1, 2 units. I'm actually going to have to move this a little bit. So 1 and then 1, 2 units for J hat. That puts J hat at negative 1, 7. So I hat again went to 1, 5. J hat went to 1, 7. So again, matrix multiplication, or negative 1, 7. Matrix multiplication is not commutative. The order in which we multiply matrices does matter. So, all right, that about does it for this video. Thanks for watching. I'll see you later.